Hey kids, Flexing Teacher Weber here. Hopefully you already watched the first video I made on why a rectangle and a parallelogram are very similar and basically have the same area calculation. Now I want to focus more on parallelograms in this video, and I want you to take a look at this parallelogram I've drawn. When you're looking at a diagram of a parallelogram, the bottom of that parallelogram represents the base. Then a straight up and down distance from the base represents the height. So in this parallelogram, there's a dotted line. That dotted line, whenever you see a dotted line on a diagram, that represents an imaginary line. And this dotted line represents the height of this parallelogram. Because you would never measure the height of something diagonally. See, this distance here, the distance that's 9 centimeters, that's not the height, because that's a diagonal line. You always measure the height straight down or straight up and down from the bottom. So in this particular parallelogram, the base is 8 centimeters and the height is 7.5 centimeters, right? And it would make sense that this diagonal line here should be taller than the height of the parallelogram because it's diagonal, right? So that's important to remember when calculating the area of a parallelogram. Base is the bottom, and the height is measured straight up and down from the base with an imaginary dotted line. Now, the math equation for parallelogram is basically the same as a rectangle because they have the same area as you saw in the last video. We just use some different words for it. Instead of saying length and width, we say base and height. So if you look at this here, to calculate the area of a parallelogram, multiply the base times the height. And the math equation we use for that is capital A for area equals B for the base, small b, and small h for the height. And we don't use a multiplication sign because we're using algebra now, and in algebra, the x usually represents a variable. So for this particular parallelogram, area equals b times h. So you would work down the page, and you would substitute in area equals, I want to have a blue pen there. Area equals 8 multiplied by 7.5. And remember, whenever we substitute in our numbers, we use parentheses for that. So then we keep working down the page. Area equals 60 centimeters squared. And that would be the area of that parallelogram. All right, let's look at another one. So right here, we have another parallelogram. Now the math equation to calculate area of a parallelogram is area equals base times height. You always start off writing your math equation. Now in this particular math equation, the base is 8.5, and the height has been measured with two diagonal lines. So this diagonal line has come out to here. I didn't explain what this square is. This square represents a right angle, so you know that this dotted line is at a right angle to the other dotted line, and it's being measured straight up and down, which is what the height needs to be measured as. So the height of this parallelogram, measured straight from the base to the top, is 12 centimeters. And 13 centimeters is just the length of that side, but it's not the height. So to continue the area calculation, area equals 8.5 multiplied by 12. And when we work that out, area equals 102 centimeters squared. Okay, so that's how you calculate the area of a parallelogram. Now let's use this area math equation a little bit more. I'm going to go to another question. Okay, calculate the height of a parallelogram with an area of 42 centimeters squared and a base of 7 centimeters. Okay, well, I want to use a little bit of algebra. We just spent a whole unit on algebra and solving equations, so I want to use some algebra for this, even though I bet a lot of you have used mental math to solve it already. So I want to use the math equation for area of a parallelogram. Area equals base times height. Now, one thing to note about math equations, we learned this last unit, you could also write this as base times height equals area. Same thing, right? So what I'd like to do here is I'd like to substitute in what I already know in this question. I'm going to substitute into the equation. So check this out. So I have an area of 42 centimeters squared. That means A is 42. And I have a base of 7 centimeters. That means B is 7. So I'm going to do this. I'm going to replace the B with 7. I'm going to keep the H the way it is because we don't know that yet. And I'm going to replace the A with 42. Now check this out. What we have here is a multiplication math equation. 7 multiplied by some unknown number H equals 42. Now if you remember how to solve math equations with multiplication, you do the opposite of multiply by 7, which is divide by 7. Divide by 7 there, divide by 7 there. 7 divided by 7 gives me 1H, and 42 divided by 7 gives me 6. Or I might say that H equals 6 centimeters. Now, probably a lot of you got that with mental math, but I want you to be able to apply your algebra understanding to this as well. So that's how we can use algebra with that math equation. Let's do another question. Calculate the base of a parallelogram with an area of 36 centimeters squared and a height of 9 centimeters. Well, this is the same kind of idea here. So I'm going to use my math equation for area of a parallelogram. A equals B times H. And this time I'll just use this equation. It doesn't matter. I'm going to substitute in what I already know. Well, I know that A is 36. I don't know what B is, so I'm going to leave B. And I know that the height is 9. Now this isn't normally how we write this. Normally we'd write this as 36 equals, and then you put the coefficient in front of the variable like that. So I'm going to write that as 36 equals 9b. And what we have here is another one of those multiplication equations. This time we want to know what b is. We have a 9 times b. Well, the opposite of multiply by 9 is to divide by 9. And you get 4, and this is going to be centimeters, equals b. So the base of this parallelogram is 4 centimeters. Again, probably a lot of you used mental math for this, but it's also really important to be able to use your algebra skills. Okay, let's look at one last question of on area of a parallelogram. I'm going to flip forward. Doink. Okay. Number 4 says, what is the area of paving stone needed to cover this patio? Well, this looks like we have another composite area question here. When I look at this, I see a rectangle, and I see a parallelogram, and I see some unknown measurements. So let's divide this into parts, and we'll name each part. I'm going to call the area of the rectangle, I'm going to call A1, and I'm going to call the parallelogram A2. Now, to calculate the area of a rectangle, we need to know the length and we need to know the width, and we've got that. It's 9 5/10 and 6. So let's write our math equation down. We're going to say A1 equals length times width. A1 equals 9.5 times 6, using those parentheses to show your multiplication. A1 equals 57 meters squared. Okay, now for A2 we have a parallelogram. Now for a parallelogram we need to have a base and the height. Well, the base of the parallelogram, this part right here, is the same as the length of the rectangle. So we know the base is 9.5. But we need to have the height. Now check this out. This distance here, the width of the rectangle is 6, so this must be 6. This straight up and down distance is 10, which means the height of the parallelogram must be 4. So, A2 equals base times height. A2 equals 9.5 times 4. A2 equals 38 meters squared. You've got your two areas now. You just need to total them up. And we've talked about this before, how labeling things is really a great way of organizing your solution. So the total is going to be 57 plus 38. 7 and 8 make 15, write down the 5, carry the 1. 5 and 3 make 8, plus 1 is 9. And don't forget units of measurement, 95 meters squared. That's going to be the total area of that patio. And then you would know how much paving stone needed to purchase to cover that patio, and then the hard part begins, the planning and the laying down of the paving stone. So now we know how to calculate area of rectangles and parallelograms. I'm going to get you to practice some of it. Make sure you've watched both videos. Flexing Teacher Weber, out.